Next experiment, determination of turns or voltage ratio of the single phase transformer. So what is the aim to determine the turns ratio? What is the turns ratio? Say, for example, in transformer, it depends on the type of the transformer, step up transformer or step down transformer. The turns will be varying. Turns ratio will be varying. Step down transformer means turns ratio is, say, for example, 2:1, like that it will come. Step up transformer means 1:2, like that. Say, for example, this side you are taking 230 volts. Step up transformer, say, for example, you want 230 into 2. 460 volts you want in the next side, in the secondary side. So that is the step up transformer. What is the turns ratio? 1:2. That's all simple. If a step down transformer, same thing, 200 voltage is to 200 voltage is the thing that you are giving. Okay, so there you need to step down to 100 voltage. So what is the turns ratio? 2:1, like that. So step down, that is the step down voltage. So that is the turns ratio. That's what we are going to calculate. What is the turns ratio and the voltage ratio? Same thing. Here, you see, turns ratio is a 2 ratio based on the voltage ratio. If the secondary and primary voltage are measured on the no load, their ratios are nearly equal to the true value. So without load, we need to calculate measurement of the primary and secondary currents in the short circuit test. It also gives the fairly accurate results. So if you short that transformer, like as you doing in your machines lab, open circuit and short circuit test, if you short and do also, you will get some accurate value. Here, how to calculate turns ratio? V2 by V1 is equal to I1 by I2. Okay, V2 by V1 is equal to I1 by I2. So whatever the voltage divided by secondary voltage divided by primary voltage equal to primary voltage divided, sorry, primary current divided by secondary current. That's all. Especially if the transformer has little leakage flux and a low core reluctance. So the transformer should have leakage flux should be less, and also reluctance should be reluctance of the core. Here is the step up transformer. Step up transformer, what we are doing is the same single phase 50 hertz 230 volts AC supply we are giving via phase and neutral, and via with the DPST switch. One DPST switch is there, one fuse is there for our safety purpose. Next, it is given to the auto transformer. This is the single phase auto transformer of 0 to 270 volts, 20 amperes auto transformer. Here there are two terminals are there, E and C. E and C is nothing but phase and neutral. Phase and neutral. So what we are doing is we are connecting a voltmeter across this phases, two phase and neutral. So that is 0 to 300 volts we are taking. Why we are going for 0 to 300 volts? In the sense, here you are giving only 230 volts. So 0 to 300 volts we are taking. That is connected to a transformer, step up transformer. As I said, say for example, this is 100 voltage, this is 200 voltage. This 100 voltage, this 200 voltage. So step up transformer. So here also what we are doing is we are connecting one more voltmeter for measuring what is the voltage coming over here. Here the same thing. In the step down transformer, what we are doing, the same thing, the same connection. Here, this is high voltage. Say for example, this is 400 voltage. This is 200 voltage. Okay, 400 bar 200 voltage transformer, step down transformer. So here also what we are doing is we are calculating the turns ratio. So what we are doing is here in the step up transformer, here also we are giving some rated voltage, whatever the LV side. Say I said no, low voltage side. Here it is 200 voltage. So by varying this auto transformer, you have to set as 200 voltage. Automatically in HV side, you'll get 400 voltage with some losses. Not 400 exactly, some 399 volts. Like that you will get 398, like that 1 or 2 volts might be you will be losing, but exactly you will get it. So due to some losses, iron and core losses, there will be a small drop, but sometimes exactly also you will get this thing voltage and current. So if you note down the current, you will be like as I said, due to some core loss, there will be a small drop in the current, small drop. but the voltage, I think it will be constant. Say whatever the voltage you are giving, this say 200 bar 400 volts means 200 voltage here means 400 voltage should come. Okay, so what is the definition of transformer? Transformer is a static device which converts one form of voltage to the another form of voltage, or one form of energy to the another form of energy without changing the frequency. So frequency here not changing. Okay, that is the definition for the transformer. Similarly, step down transformer, same thing. So here what we are doing is, here you are giving the some 250 voltages bar 110 voltage, 230 volt bar 110 volt. So 230 here you are giving. So automatically you will feel the 110 voltage here. After that, you are just calculating the turns ratio. Here you are noting down all the values here, and again here you are noting down the turns ratio. Yeah, here turns ratios V2 by V1. Very simple. Like 400 divided by 200. That's all. You will get the answer. As turns ratio, what is turns ratio? 400 divided by 200 is what? 200 divided by 200 is 2. Like that, you'll get the ratios. For step-up transformer, what is the turns ratio? For step-down transformer, what is the turns ratio? So here, the same thing. Here, step up means step down means 400 divided by 200. Step up means 200 divided by 400 divided by 200. So that you will get 2. Okay. So for a step down, step down means you will get 2. For step up means you will get 1 by 2. Like you will get the answer like that. Based on that, you need to write the conclusion. What is the conclusion? The turns ratio of a given transformer, like step up or step up transformer, is noted down like that.